Betelgeuse is an enormous star estimated to be around 15 to 20 times the mass of our Sun. It is currently nearing the end of its life cycle, making it a massive, luminous, and fascinating celestial body. At some point in the future, Betelgeuse is expected to go boom, resulting in a supernova explosion. Recently, renowned physicist Brian Cox has provided the world with something to think about. According to him, one of the brightest stars in the night sky, Betelgeuse, the famous red giant star, is on the verge of a supernova explosion. The data received by astronomers further supports this claim, confirming that the star may indeed be heading toward an impending catastrophe. This leads to a critical question. Are we about to witness a disastrous supernova explosion, or is it just speculation? To answer this, we must examine the dangers surrounding Betelgeuse and take a closer look at Brian Cox's warning regarding its potential supernova event. Betelgeuse is a giant red star of extraordinary proportions. It has earned its name due to its distinct brightness, which makes it shine more brightly than many of its stellar counterparts. This fascinating celestial body is situated in the Orion constellation, specifically at the left shoulder of the iconic figure outlined by the constellation. While Betelgeuse has long been a recognizable feature in the night sky, its unique characteristics have led to increased scientific curiosity and interest. Unlike regular stars, Betelgeuse stands out due to its massive size and distinct behavior. Typically, a star is classified as a regular supernova candidate if it possesses a mass at least 8 times that of the Sun. However, Betelgeuse breaks all conventional expectations. It is more than 700 times the size of the Sun, a scale that surpasses anything we can easily comprehend, and it is approximately 15,000 times more luminous. The recognition of this giant star dates back to ancient times, with its first recorded observations traced to the Greek astronomer Claudius Ptolemy. His observations were limited due to the tools available at the time, as early astronomers could only determine a star's color and position rather than its more detailed properties. With the advancement of modern scientific instruments and investigations, the study of celestial bodies like Betelgeuse has become much more detailed, allowing astronomers to gain valuable insights into their properties and life cycles. Currently, Betelgeuse appears to be aging, increasing in mass as it progresses through its stellar evolution. Based on astronomical measurements, the star is estimated to be between 8 and 8.5 million years old. In the context of stellar life cycles, this is considered relatively old, yet in human terms, it is still quite young. If we could visualize its vast size, Betelgeuse would likely displace the first 4 planets in our solar system, Mercury, Venus, Earth, and Mars, if it were placed in the center of our solar system. The question of how this giant red star accumulated such immense mass continues to puzzle scientists, driving ongoing research and exploration. Scientists have determined that Betelgeuse's enormous size is not a random occurrence, but a natural stage in its stellar life cycle. As it progresses through its evolution, the star has entered what is known as the twilight phase, which is characterized by expansion, cooling, and the fusion of hydrogen into helium at its core. Currently, Betelgeuse is in the supergiant phase, a stage that results from millions of years of evolution. This transformation from a hot blue star to a giant red one is largely influenced by the forces of nuclear fusion and gravity. One of the most striking features of Betelgeuse is its color. Unlike hotter stars such as the Sun, which emit light at shorter wavelengths, Betelgeuse has a lower surface temperature, causing it to emit light at longer wavelengths, which appear red. While the Sun has a surface temperature of approximately 5,500 Kelvin K, Betelgeuse's surface temperature is only about 3,500 K. This temperature difference causes Betelgeuse to shine with its distinct reddish hue. The change in color over time is not merely an aesthetic trait, but provides valuable information about the star's condition, gaseous composition, and evolutionary state. Ancient Chinese and Roman texts indicate that Betelgeuse was not always red. Around 2,000 years ago, historical records suggest that it was once yellow. The first definitive account of Betelgeuse appearing red dates back to the 9th century, as described by Arabic scholars. This provides a crucial clue regarding the star's evolutionary journey. Another fascinating aspect of Betelgeuse is its brightness. Unlike stable stars, Betelgeuse is classified as a semi-variable star, meaning that the intensity of its light fluctuates over time. This variability in luminosity has intrigued astronomers and astrophysicists for centuries. Typically, Betelgeuse follows a 400-day brightness cycle, along with a longer cycle lasting approximately 5 years. These fluctuations were first documented in 1836 by Sir John Herschel and may have been recognized even earlier by Aboriginal oral traditions. However, Betelgeuse's brightness does not follow a predictable pattern. Unlike most stars which exhibit steady brightness changes, Betelgeuse dims and brightens irregularly. This inconsistency makes it an especially interesting subject for astronomical research. In 2019, Betelgeuse captivated the attention of astronomers and stargazers worldwide with an unexpected and dramatic dimming event, later termed the Great Dimming. The reduction in brightness was so abrupt and intense that by February 2020, Betelgeuse had reached its lowest recorded luminosity. Observations indicated that Betelgeuse typically dims every 430 days, with a longer cycle of 6 years. During these cycles, dark star spots, regions of intense magnetic activity, appear on its surface. This led scientists to investigate the cause of the unprecedented dimming. Was Betelgeuse on the verge of exploding, or was there another explanation? Using advanced telescopes such as the Hubble Space Telescope and the Atacama Large Millimeter/Submillimeter Array, ALMA, in Chile, astronomers discovered that the Great Dimming was caused by the ejection of hot material from Betelgeuse's surface. This ejected material eventually cooled and condensed into a dust cloud, which partially obscured the star's light from our view. This finding was groundbreaking, as it revealed new insights into the mass loss processes of dying stars. Recent data from gravitational wave readings have raised further concerns. Although astronomers expect Betelgeuse to explode eventually, the exact timing remains uncertain. While some scientists believe the star's recent activity suggests an imminent supernova, others argue that it could still take thousands or even millions of years before it reaches that stage. If Betelgeuse were to go supernova in the near future, what would be the consequences for Earth? Some theories suggest that the explosion would unleash a massive burst of gamma radiation, which could have devastating effects on our planet's atmosphere. However, because Betelgeuse is approximately 725 light-years away, scientists believe that its explosion would not pose a direct threat to life on Earth. Instead, it would be a spectacular astronomical event visible even during the daytime. Despite the uncertainties surrounding Betelgeuse's fate, its eventual supernova explosion will provide scientists with an unprecedented opportunity to study stellar death up close. Astronomers continue to monitor Betelgeuse using cutting-edge instruments such as the James Webb Space Telescope, which offers new insights into its behavior. Ultimately, whether Betelgeuse will explode in our lifetime remains unknown. But one thing is certain: its eventual supernova will be one of the most extraordinary celestial events ever witnessed by humanity.